Hello and welcome to this video. We're going to learn how to find the eigenvalues of a 2x2 matrix. So let's have a 2x2 matrix, 2, 2, 3, and 1. So let's call this matrix A. So that is matrix A. So the eigenvalues of this matrix, okay, so let me also have A minus lambda I is equal to 0. So the eigenvalues of this matrix are values, they are the values of lambda that satisfy this equation, that matrix A minus lambda times I stands for the identity matrix, and then we find the determinant of this whole thing. It should give us 0, and that is what I want us to work out. So we have matrix A as 2, 2, 3, 1. So we subtract lambda times identity matrix over 2x2 matrix. It's 1, 1, 0, 0. And then the determinant of the whole of this should be 0. So let's multiply lambda by the identity matrix. So lambda is a scalar. We are going to treat it as a scalar. And so when we multiply this, it's going to be lambda, 0, and 0. And then we now subtract that from matrix A, which is 2, 2, 3, 1. And then still we are finding the determinant of this whole thing, and we should get 0. Okay, so let's subtract this. 2 minus lambda is 2 minus lambda. It will remain that way, and then 2 minus 0 is 2, and then 3 minus 0 is 3, and 1 minus lambda, we're going to write it that way. And then we now find the determinant of this matrix, and we should get 0. Okay, so in the past we learned how to find the determinant of a 2x2 matrix, and we said that if we have a matrix, a 2x2 matrix A, B, C, D, the determinant is equal to the product of this diagonal minus the product of this other diagonal, that is AD minus BC. And we shall do that the same for this case. We're going to have 2 minus lambda, we multiply by 1 minus lambda, and then we subtract the product of this other diagonal, which is 3 times 2, which is 6, and this should give us 0. So we need to work out this. Let's expand this. We're going to have 2, we multiply by 1 minus lambda, and then minus lambda, we multiply by 1 minus lambda, and then minus 6, this should give us 0. So when we open the brackets, we're going to have 2 minus 2 lambda, and then minus lambda plus lambda squared minus 6 should give us 0. So we can put like terms together. We have 2 minus 6, it's going to be negative 4, and then minus 2 lambda minus lambda is going to be minus 3 lambda, and then plus lambda squared, this should give us 0. So we can rearrange this. So let's rearrange this. Let me use a different color. So we're going to have lambda squared minus 3 lambda minus 4 is equal to 0. So this is a quadratic equation. We are supposed to solve for the values of lambda, and there are many ways of doing that. You can decide to use the factorization method or the quadratic formula and many others. So let's use the factorization method. So we're going to look for two numbers whose sum is negative 3 and whose product is negative 4. So just try to figure out what these two numbers are. Their sum is -3 and their product is -4. So it turns out that these two numbers are -4 and 1. So we can confirm whether they are actually the ones. So -4 plus 1 is -3, and then -4 times 1 is -4. So those are the two numbers. So what we then do, we are going to have a lambda squared, and then we rewrite -3 lambda as -4 lambda plus lambda, and then -4, this should be 0, and then we're going to group it that way and then factor out lambda so that we have lambda -4, and then of this other one we're going to still have lambda -4. So when is equal to 0. So the value that we're going to put here to multiply this bracket with, so that we get this, is going to be +1. Okay, so we're going to group them as lambda +1 and lambda -4 is equal to 0. Okay, so we're going to have lambda +1 is equal to 0 and lambda -4 is equal to 0. So lambda is equal to -1 and lambda is equal to 4. So these are the two values of lambda, and these are going to be our eigenvectors. So I want us to confirm whether if we fix the two values to this equation that I had written here, whether we're going to get 0. Okay, so we can go back here, so we can fix the values of lambda. Let's start with lambda is equal to -1. So we are going to replace lambda with -1. So we're going to have this matrix as 2 minus negative lambda. So that is 2 plus 1 is going to be 3. And then we have 2, and then we have 3, and we have 1 minus lambda. It's 1 minus -1. So that is 1 plus 1 is 2. So we find the determinant of this and check whether we are going to get 0. So we know that the determinant is found by the product of this diagonal minus the product of this other diagonal. So it's 6 minus 6, which is equal to 0. So you can say that the value of lambda, that is -1, satisfies that equation. So that is one of the eigenvalues. Let's check the other one, that is lambda is equal to 4. Lambda is equal to 4. Let's check that out. So we still go back here and replace lambda with 4. So the matrix is going to be, okay, let me clear up some space here. Okay, so the matrix is going to be 2 minus lambda, that is 2 minus 4, it's going to be -2, and then we have 2, and then we have 3, and we have 1 minus 4 is -3. So I want us to check whether it's going to be the value of, or rather the value of lambda is going to fit in that equation. So the determinant of this should be 0. So it's -3 times -2, which is 6. So that is the product of that diagonal. And then we subtract the product of this other diagonal, which is 6. And that is equal to 0. So you can see that lambda is equal to 4 is also an eigenvalue of that matrix. So these two are the eigenvalues. And in the next video, I'm going to show you how we can find the eigenvectors from these eigenvalues. So let's meet in the next video.